Hello, everyone, and welcome to this next episode of Statics, where we're going to be determining the magnitude here of a fairly basic force and the angle at which it acts. So this question essentially asks, not given, but there's a force F1, and it's acting in a direction theta, and essentially it wants to know what that direction is and what the force has to be so that the magnitude is equivalent to 800 newtons. So how do we solve this? Well, the first thing I like to do is I typically work in variables, and so I'm going to call this angle 30 degrees here. I'm going to call it sigma, and you can also make an angle here if you want to, doing the arctangent of the opposite over the adjacent, which is 3/4, or you can do it the easier way. You can call this phi, but you can do it an easier way where the component in the x direction is in fact given by just multiplying the x component divided by 5, or the hypotenuse. And this is the same thing that works in the y direction as well, where you can do 3/5 multiplying your force by 3/5 to get the y component. So let's go ahead and now do the next biggest thing, which is to do the free body diagram. So we're going to be talking about this little O-ring point here. And so let's draw the free body diagram for that O-ring. So at the O-ring, what do we have? Well, we have a force. Actually, I'm going to go ahead and draw my axes out first. So we have an x and a y. We have a force acting at 400 newtons, and it is at some angle sigma. And we have another force here acting at theta, and this is F1. And we have another force here, 600 newtons, acting as a 3, 4, 5 triangle. So 3, 4, and 5. So now that we have our axes and our free body diagram built up, we're going to go ahead and move on to the sums of forces equation. So we're going to need to do the sums of forces in the x and the sums of forces in the y. Sums of forces in the x, what do we have? Well, we want to grab the component of the x here for this 400 Newton force. So how do we do that? Well, we know that we can do 400, obviously. And how do we grab this component? Well, we have to use our trig rules, which is SOHCAHTOA. And we want basically the adjacent leg here. So we see that we can find the adjacent by doing the cosine of this angle is equal to the adjacent over the hypotenuse. Hypotenuse is always equal to the force, because that's just how this works out. So that means that essentially we can just do, obviously multiplying by the h, which is 400. We can do 400 cosine of this angle sigma, and that's our x direction, or x component of this vector. And then we're going to add this to the x component of this f1, which would be the sine of this angle theta. Why is it the sine? Same thing, but it's the opposite here from this angle, so that's going to be so. And now we're looking at the other side. Well, the other side is now behind the y-axis on the left side. So what does that mean? That means we have to put a negative 600. And how do we get that angle using the 3, 4, 5 rule? As I explained before, we can just take the side, so the 4, because that's the x side here, and then divide that by the hypotenuse, and that gives you your component in the x direction. Now, in the x, it's not moving, so it's equal to 0. So now we're going to go do the sums of forces in the y. In the y, we have 400 sine sigma, because it's just going to be the opposite, plus f1 cosine theta, plus 600, but now we want this y component, so it's going to be 3/5. And this, as it's going to be moving 800 newtons, it's going to have a net force going upwards at 800 newtons. We're going to need to set this equal to 800. Cool. So now we have our two written out things that we want to write out to be able to solve for this. So how can we go ahead and solve for theta? Well, by recognizing that sine over cosine is equal to a tangent, we can actually rearrange the sums of forces in the y equation so we can get a tangent in the denominator. And I'll show you exactly what I mean by that. So I see this equation. I'm going to go ahead and move over everything that's not this term to the right-hand side. So we're going to get f1 cosine theta is equal to 800 minus 600 times 3/5 minus 400 times sine sigma. And then now I'm going to go ahead and divide this by cosine theta. So I'm going to have 800 minus 600 times 3/5 minus 400 sine sigma, all divided by cosine theta. And now I'm going to go ahead and plug this in to the f1 here, because that's how we have to solve for it if we have two unknowns and two variables. So we're going to have 400 cosine sigma plus 800 minus 600 times 3/5 minus 400 sine sigma, all divided by cosine theta, and then all of this is divided or multiplied by sine theta. We're going to subtract by 600 4/5, and this equals 0. So now, you see we have this cosine in the denominator and the sine in the numerator. We can convert that into a tangent, and we're just going to move this side over to the right-hand side and this over to the right-hand side so we can start solving. So what does that mean? That means I have a tan theta times 800 minus 600 times 3/5 minus 400 sine sigma is equal to 600 times 4/5 minus 400 cosine sigma. And now I'm just going to divide this out and take the arctangent, and that's going to give me my angle. So that means I'm going to have theta is going to be equal to 600 times 4/5 minus 400 times cosine theta, or sigma. Divide that all by 800 minus 600 times 3/5 minus 400 sine sigma. And this is the arctangent of all of this, actually, so arctangent. And so let's go ahead and calculate that out. What do we get as our angle theta? So we'll do 600 times 4 divided by 5. That is 480. And then 400 times cosine of 30. That's 346. So we're going to have 480 minus 346. That's 133 times 3 divided by 5. 400 times sine of 30. And then 800 minus 360 minus 200. It's 240. And we're going to take the arctangent of that value, and we get a angle of 29.1 degrees. So that is our angle. And now we want to solve for this F1 force. So how do we do that? Well, really we can just plug this value all the way back into here, and that should give us the F1 force. So F1 is going to be equal to 800 minus 600 times 3/5 minus 400 times sine of 30, all divided by cosine of 29.1. And so let's go and plug that in, and I'll get the answer for you. So we'll have here 600 times 3 divided by 5, and then 800 minus that value. And we'll have sine 30. We'll have 400 times that value. And we'll do the 440 minus 200. And we'll go and do the cosine of 29.1. And we'll divide those values. And we have a force value of 274.67 newtons. So now we have our angle and our force, and if you were to check these values, you would get a positive net force in the y direction going at 800 newtons. So thank you.